So dear students, let us study about gravitation. It is a topic of class 9th ICSE physics from the chapter Laws of Motion. We are going to study about Newton's law of gravitation, its importance, acceleration due to gravity, relation between G and capital G, relation between mass and weight, gravitational unit of force, and a few numericals. Gravitation. Let us study universal law of gravitation. Every mass on this universe attracts every other mass particle with a force of attraction. This force of attraction is called gravitational force of attraction. And Sir Isaac Newton gave the magnitude of this force of attraction in the form of a law which is called universal law of gravitation. Let us see what is the law. Consider two mass particles m1 and m2. These are the two masses between which we will find out the force of attraction, gravitational force of attraction. They are separated by a distance small r. Here F12 is the force exerted on mass m due to mass 2, and F21 is the force exerted on mass 2 due to mass 1. F is directly proportional to the product of these masses and is inversely proportional to the square of the distance between the two. On combining the two, we get this, and on removing the constant of proportionality, you get F is equal to G m1 m2 upon r square. This is the mathematical form of universal law of gravitation, and using this you can find out the magnitude of force of attraction between the two masses. Here the masses considered are m1 and m2. What is G? G is known as constant of proportion. G is the constant of proportionality. It is known as gravitational constant. What is its SI unit? Using the formula, G is equal to F into R square over M1 into M2, which we obtained from here. We get SI unit of G as Newton meter square kg inverse square, and its value is 6.67 into 10 power minus 11 Newton meter square kg inverse square. Let us calculate this gravitational force of attraction between moon and the earth. Let us see how much is this force, how much is the magnitude of the force. For that, we know that our formula is F is equal to G m1 m2 upon r square. So m1, let it be the mass of moon, which is taken as 7.36 into 10 power 22 kg, m2 mass of earth 5.96 into 10 power 24 kg, and upon r square. R is the distance of moon from the earth, that is 3.80 into 10 power 8 meter. So after substituting the values of G, m1, m2 and r, what is the magnitude of force obtained? It is 2 into 10 power 20 Newton, which is quite a large magnitude. Why I am saying so? Let us see in comparison to this a calculation of force between any two masses on the surface of Earth. These were the heavenly bodies. Let us say on the surface of Earth, if we have mass 1 of magnitude 1 kg, mass 2 of magnitude again 1 kg, and distance between them is 1 meter, then what will be the magnitude of the force? Substituting the value of G, m1, m2 and r, we get F is equal to 6.67 into 10 power minus 11. So in comparison to 10 power 20, 10 power minus 11 is a very, very small value. Thus, what is the conclusion after these two calculations? It was concluded that the gravitational force of attraction is highly significant between heavenly bodies, but it is insignificant between ordinary bodies. And we should also know that this force of attraction, gravitational force between the two bodies, is always of attractive nature. It is always attractive in nature. So why two persons on the surface of earth do not attract each other? Why we do not come towards each other if we are at a distance of 1 meter? The reason is, this calculation is the answer. The reason is that the magnitude of the force of attraction is very, very small, almost negligible. Now, what is thus the importance? The importance of this law is law of gravitation. Newton used this law to explain the motion of planets around the sun, the motion of moon, which is the satellite of earth, motion of moon around the earth, and to explain the motion of a freely falling body. Now, based on this law again, let us define force due to gravity. The force with which earth attracts a body towards its center is called force due to gravity on the body, which can be taken to act vertically downward at the center of gravity of the body. In vertical motion near the earth's surface, for height much smaller than the radius of the earth, the force of the gravity on the body is assumed to be same. So, how we will write mathematical form of force due to gravity? It is F is equal to G m1 m2, you know. So here 1 m is mass of the earth, and another m, that is m2, will be written as small m, that is mass of a body. And r square we have in the formula. So for that, r will be taken as the radius of earth, because any body, any object present on the surface of earth, when it is raised up from the earth, the distance is very less as compared to the radius of the earth. So that distance we need not to add. And we will consider the distance of separation between mass and the body as equal to mass radius of earth, which is 6.37 into 10 power 6 meter. Let us calculate the magnitude of this force due to gravity. This force, on substituting the values, comes out to be 9.8 Newton. That is, earth attracts a body of mass 1 kg by a force of 9.8 Newton towards its center. Based on this, we can define acceleration due to gravity. Before that, I want to tell you that as earth attracts an object towards it, does the object also attracts the earth towards it? Yes, children, object also attracts the earth towards it by an equal force. But since the object is free to move, so it starts moving towards the earth. But earth, because of its large inertia, large mass, does not move towards the object. Now let us study what is acceleration due to gravity. Galileo studied the motion of different bodies under the force of attraction of Earth, and he made the following conclusions. Bodies of different masses and sizes, if fall in vacuum from the same height, they reach Earth simultaneously and with the same velocity. Now, why we have written in vacuum? Because in the presence of air, some viscous forces and bind forces, they act on the body in the upward direction. And these bodies, these forces which depend upon the size, shape and velocity of the body, then the bodies will not reach the earth in the same time, because these viscous forces will make the difference, will bring the difference in the velocity of the body which is falling downward. So we have considered, Galileo considered that the bodies are falling in vacuum from the same height. So it was observed that they reach earth in the same time. Then secondly, the motion of the bodies is a uniformly accelerated motion. That means the velocity of the falling body is not constant, but it increases at a constant rate, which is called uniformly accelerated motion. And this acceleration is same for all the bodies. So any body, any shape and size falling in vacuum on the surface of Earth will get accelerated with the same value, same acceleration. This acceleration is called the acceleration due to gravity. And this acceleration of a freely falling body, it does not depend on the mass of the body, its size and its shape. If we are taking vacuum, then different masses, different sizes, all body will fall on the Earth with the same acceleration. It is denoted by, acceleration due to gravity is denoted by small g. Its SI unit is meter per second square. It's a vector quantity. Since it is a vector quantity, what will be its direction? It will be directed vertically downwards towards the center of Earth. Then its value is found to be 9.8 meter per second square. And the value of g varies from place to place. On equator, it is slightly less than the value of g at poles. We have considered 9.8 meter per second square as the mean value of g. At different places of Earth, the value of g is calculated. And what is the mean value? 9.8 meter per second square. Also, the value of g is 0 at the center of Earth. At the center of Earth, the value of acceleration due to gravity is 0. One more thing, at altitudes above the Earth's surface, as you go up from the surface of Earth, the value of g decreases, and as you go down from the surface of Earth towards its center, the value of g again decreases and becomes 0 at the center of the Earth. The value of g is also different on different planets and satellites. You know that on the value of g on moon surface is 1/6 of the value of g on the Earth's surface. Let us find out the relation between small g and capital G. Small g is acceleration due to gravity and capital G is gravitational constant. Now from second law of motion, we know that F is equal to mass into acceleration. If we consider acceleration due to gravity here, then you will write it as F is equal to mg. And then from Newton's gravitational law, we can write for Earth and a mass, we write F is equal to G capital M small m upon r square, where m is the mass of Earth and small m is mass of the body on the surface of Earth. R is the distance of that body from the Earth, which is radius of Earth. If we join these two equations, what do you get? Since left hand side is same, we will write it as mg is equal to g mm upon r square. M and m, two masses, the two values will get cancelled and you get small g is equal to gm upon r square. This is the relation between acceleration due to gravity and gravitational constant. Our next topic will be comparison between mass and weight. You should know what is mass, what is weight, and we will find a relation between mass and weight. Mass is a scalar quantity. It is the intrinsic property of the body. It is measured by a physical balance. Its SI unit is kg, and it tells us about the quantity of matter present in a body. Then you should also know that mass of a body remains same as we go from one place to another. It does not change by changing the place of the body. We here will denote it by, it is generally denoted by small letter m. Then what is weight? Weight of a body is the force with which the earth attracts it, or it is the force of gravity on a body. So weight is a force. What will be its SI unit? SI unit is Newton. and it is denoted by capital W. What is the relation between mass and weight? The weight of the body is related to mass, as we write W is equal to mass into acceleration due to gravity. Why? Because W is a force. So you know from Newton's second law, force is equal to mass into acceleration. So W is equal to mass into acceleration due to gravity. Therefore, W is equal to mg. Now, next topic, let us study units, some gravitational, let us know about gravitational units of force. In MK system, it is 1 kgf. Since it is force, so it will be the product of mass and acceleration. So force 1 kgf is the force due to gravity. Since we are talking of gravitational unit of force, so it is force due to gravity on a mass of 1 kg. And here value of g, when we substitute mass, we take as 1 kg. G is the acceleration due to gravity, and value of g is 9.8. So we get, substitute the value of g here. Kg meter per second square is written as Newton. So 1 kgf is equal to 9.8 Newton. Then in CGS system, what is the value for gram force? Similarly, if we define it and find out the value, 1 gram force will be equal to g, acceleration due to gravity, dyne. Dyne is gram centimeter per second square. And for CGS system, value of g is 980 dyne. So here, if we want to make an approximation for 1 kilogram force, so 1 kilogram force is nearly equal to 10 Newton. That means we have to exert a force of 9.8 Newton to hold a mass of 1 kg on our palm. Now let us solve a few numericals which I have taken from your Concise Physics Selena, page number 80. And I have written the question numbers same as given in the book. Let us read question 1. The force of attraction between two bodies at a certain separation is 10 Newton. What will be the force of attraction between them if the separation is reduced to half? So given is force 10 Newton. We know that according to universal law of gravitation, force is inversely proportional to square of the distance between the two bodies. Now if r becomes half, in place of r you will write r by 2. When you solve it, you will get r square by 4. 4 we take to the numerator, and then we write it separately as 4 into 1 by r square. So what is the value of this f equal to 1 by r square? It was 10. Now, or you can say that after r becomes half, the force becomes 4 times. So if the value of force is 10 Newton, then now the new force with the radius halved becomes 4 into 10 is equal to 40 Newton. Question number 3. Calculate the weight of a body of mass 10 kg in kgf and in Newton. Mass is given 10 kg. What is the weight in kgf? We know that kgf is equal to mass into force of gravity. So it is force due to gravity on a mass of 1 kg. So that is equal to 10 kgf, because force of gravity will be written as F only, and in place of mass you will write 10 kg. Then in SI system, W is equal to mg. We know that relation between weight and mass, W is equal to mg. So your W comes out to be 98 Newton on solving. Question number 6. The weight of a body on Earth is 98 Newton when the acceleration due to gravity, where the acceleration due to gravity is 9.8 meter per second square. What will be its mass? And second, its weight on Moon, where the acceleration due to gravity is 1.6 meter per second square. Its mass on Moon, since weight is given as 98 Newton, first we will calculate its mass on Earth. So mass is equal to weight upon g, because we know W is equal to mg, m is equal to W upon g. 98 Newton upon 9.8 meter per second square, 10 kg. And since mass of the body does not change from place to place, so its mass on moon also will be 10 kg. Then weight on moon, you need to know the acceleration due to gravity on moon, which is given. Mass 10 kg, acceleration due to gravity given 1.6 meter per second square. On solving, weight of the body on moon comes out to be 16 Newton. Question number 8. What is the force of gravity and weight of block of mass 10.5 kg? Take G is equal to 10 meter per second square. Now you have to find force of gravity. That means you are asked about the weight of the object. What is weight? Weight is the force of gravity acting on a mass. So here force of gravity is equal to mass into acceleration due to gravity. In the question it is given, take G as 10 meter per second square. So you have to take that value only. So that is equal to 10.5 into 10 is equal to 105 Newton. And what is the weight of the block? Force of gravity and weight are same. So if you calculated force of gravity to be 105 Newton, weight of the block will also be 105 Newton. Children, I hope you have understood universal law of gravitation clearly and the method to solve numericals. Thank you.